Hello students, welcome to this lecture number 5 on the structure of the atoms. In this lecture we are going to discuss a very important topic, that is nature of the electromagnetic radiations. And myself K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. See students, this is basically a free service to the students. They don't have much of the capability. They can see this video, and I am very much sure that they will going to be benefited out of it, because it does not require any money or anything expenditure that on the part you have to make. You can, without any cost, you can subscribe, you can like, and you can see all those videos without any cost. It is free of cost. That is basically a service to these students of this country. So in this video we are going to discuss the nature of electromagnetic radiations. First, let us understand what is the history behind it. Till 19th century, it was believed that light is made of particles. Light is made of particles as proposed by the great scientist Isaac Newton in 18th century. In the year 1870, Maxwell, the great scientist, again highlighted on the nature of the light. He said that light is basically a electromagnetic wave, we can say, or electromagnetic radiation. That is a very interesting point, interesting milestone of the scientific journey. Okay. So in 1870, Maxwell said that the nature of the light is wave. Suppose an electron is revolving in a circuit, revolving in a circular path, suppose. At that time, it is accelerating. It tells that when this type of charged bodies has accelerated, then it will create an electric and magnetic field. You can see from this diagram, this is when the charged particle oscillates, or you can say accelerates, then there is a electric field and this magnetic field has been created. You can see the bold line is the electric field and this dotted line is the magnetic field. And you can see one thing, this electric field and magnetic field is perpendicular to each other, and this field will transmit it, it will propagate it at the 90-degree angles with this electric field and the magnetic field, and this is called the electromagnetic wave, or we can say electromagnetic radiation. This is very much new to the scientist, and it is founded, it is given by the great scientist Maxwell. So light is also correlates with this accelerating electric field and the magnetic field, and light wave is created in this fashion. Now we will discuss the characteristics of the electromagnetic radiation. Magnetic radiation, I give a short form EMR, electromagnetic radiation. What is first? That it says the energy, let us write, energy is emitted from a source continuously and propagated in the form of wave, and this is called the radiant energy. Number 2 points. So energy is emitted from the source continuously. There is no discontinuity in the supply of the energy. Energy is releasing continuously from the source. And this is a very, very important thing to understand. Continuously. Then, there is a lot of waves you can see, that is sound waves, water waves, but they are different from this electromagnetic wave. How? Now, electromagnetic wave can travel. So we make a short form, EMR. We say the EMR, electromagnetic radiation, or we can say electromagnetic wave is travels, you can say travel at, it will travel without the help of any medium. Without the help of any medium, because it does not require any medium. As we can see, it is required for the sound wave or the water wave. So electromagnetic radiation or electromagnetic wave is basically can travel at the vacuum, right? The EMR that travel with this, and the speed of the electromagnetic radiation is 3 into 10 to the power 8 meter per second. That is the speed of the light. We can say this is the speed of light. So you understand the 3 important characteristics of the electromagnetic radiation or electromagnetic wave. That is, the energy is emitted from the source continuously. Number 1. Number 2, that it travels without the help of any medium. The speed of the electromagnetic radiation is this. Electrolight is a form of electromagnetic radiation, but there are also several sources of electromagnetic radiation we can also found out, and those are basically and those are, you can see, their wavelength and their frequency is totally different from each other, and these will form the electromagnetic radiation spectrum. And you can see the arrangement of this electromagnetic radiations in increasing order of the wavelength is called the electromagnetic spectrum. Now you can understand the electromagnetic spectrum. What is that? It is the arrangement of radiations, that is the electromagnetic radiation, in order of increasing the wavelength. The electromagnetic radiation which have the lowest wavelength, that is your gamma rays. Gamma rays have the lowest wavelength. It is followed by X-rays. Then it is having the ultraviolet rays. This is X-ray and this is ultraviolet ray. And after that we will find the visible range. That is a small part of this electromagnetic spectrum, visible range. And then this is the infrared, and then microwave, and then it is radio wave. This is all the electromagnetic radiations. It has been put in a order of increasing the wavelength. So we can write wavelength in increasing order. Wavelength in increasing order. Increasing order. In the visible range that we used to see, that is, it is called a VGO, and its frequency, its wavelength is ranging from 400 nanometer to 760 nanometers. VGO is violet, indigo, blue, green, violet, blue, green, yellow, orange and red. Violet has the least frequency, wavelength, highest frequency, and red has the highest wavelength and the least frequency. So this is the electromagnetic spectrum. Now the wave is characterized by different parameters that we are going to discuss. Now we are going to discuss the characteristics of the wave. And before going to discuss all those characteristics, let us understand what is wave. What do we mean by the wave? Wave is basically, it is a disturbance. You can see, it is a disturbance. Because when we are thinking anything, that creates a wave, and this wave also is electromagnetic wave, that it goes from here and there. When you go to the temple, you feel very silent, very peaceful. Why? Because there is a wave, you can see that wave creates a peace in yourself. So that is different spiritual thing. Now what is wave? Wave is a disturbance. Wave is a disturbance created by a source and travel. It create and also it travel. It travel outwards. It travel outwards continuously in a alternate sequence. In an alternate sequence of crest and taff. crest and trough. So wave is basically a disturbance created by a source and travel outwards continuously in an alternate sequence of the crest and trough. So you can see what. So this is the wavelength and this is the wavelength, and the unit of the wavelength, unit in the SI unit, it is meter, or you can use the angstrom, nanometer, all the things you can use, meter. Then the another thing, that is the amplitude. Another property of the wave is amplitude, and this is being represented by A. This is amplitude. Amplitude is what? It is the height of the crest. Height of the crest and depth, or the depth, or we can say or the depth of trough. Wavelength, that is the linear distance between two nearest crest and trough. The unit is meter. Amplitude is represented by A. This is the height of the crest or depth. This is the amplitude of the wave. That is the one of the parameters of the wave. Then third number point, that is the frequency. Frequency of the wave. It is represented by mu. This is the frequency of the wave. It is the number of waves. Number of waves that pass through a point per unit time. Number of waves that pass through a point per unit time, and its unit is hertz. Unit is Hj hertz. That is cycles, or you can say waves per second. Waves per second. So this is the frequency. Now another point, that is the velocity. Velocity of the wave is represented by c. It is the linear distance. It is the linear distance traveled by wave in unit time. The velocity of the electromagnetic wave, velocity of electromagnetic wave is 3 into 10 to the power 8 meter per second, or 3 into 10 to the power 10 centimeter per second. This is the speed of the light. Now there is a relation between these three important parameters, that is the wavelength, frequency and the velocity. What is this relation? We know, already we have discussed when we were discussing the electromagnetic spectrum, that it is the frequency and the wavelength, they are related inversely. So we can say if the wavelength of this electromagnetic radiation is lambda, it will be inversely related to the frequency. So you can see that lambda is equal to C by nu. C by nu, मतलब whether frequency wavelength is higher, means it will have the lesser frequency. So this is the relation, very important relation. C, speed of the electromagnetic wave, is equal to lambda into mu. That is the wavelength into speed of this. Okay. That is the most important characteristic that we have discussed with the definition, that is the wave has different characteristics, that is its wavelength, speed, its amplitude, its frequency. All the things that you must remember, because for calculation purpose you will need it. Okay. Now we will have one examples which type of questions, numericals may come. This is one very important question, very relevant questions that numerical I have given to you. That is the wavelength of visible light spectrum extend from violet to red, that is 400 nanometer to 750 nanometer. Express in the wavelength in frequency, because you have been given the wavelength, you have to represent in the frequency. So what relation you have to exploit? This is, you know, the when frequency is basically speed of the light, speed of this electromagnetic radiation divided by lambda. This relation you have to exploit, and this is a very important relation, and you have to know this. First, let us understand from the wavelength of this violet. Violet wavelength is 400 nanometer, means lambda is 400. We have to convert it into the meter. Meter means 400 into nanometer, means 10 to the power minus 9. 1 nanometer, you know, that is equal to 10 to the power minus 9 meter. Okay. Then thus this is the lambda of the radiation, that is lambda. This frequency will be the speed of the light, we know, 3 into 10 to the power 8 meter per second, divided by this nanometer is 400 into 10 to the power minus 9 meter. Okay, and from this we can calculate this. It will give 7.5 into 10 to the power of 14 hertz. You can calculate this, you will get this, because here you can see these two zero has been cut into 10 to the 6. So this will coming to the top, it will 10 to the 15, and you will calculate this. Then frequency of your rate, frequency of the rate, that is given by the lambda of rate is, first lambda rate, it is given 750 nanometer, means 750 into 10 to the power 9 meter. You have to convert this into meter. Then rate, frequency of the red light is given by 750 speed of the light. We have to take the speed of the light first, 10 to the power 8, then 750 into 10 to the power 9, and it will be coming around that you got it. This is a 10 to the power 7 and the 25. Then you will get 4 into 10 to the power 14 Hertz. Okay. Now do 25 and it will become here 2 watt will be there, and it will be this. So you can see the frequency of the violet light is 7.5 into 10 to the 14 Hertz, whereas frequency of the red light is 4 into 10 to the 14 Hertz. So as the wavelength is increasing, the frequency also decreasing. That you can see from this example. And that is all for today's video. Hope you enjoy this video. If you like this video, you can share to your friends. And in the next video, we will discuss the part 2 of the nature of the electromagnetic radiation. Because this is the wave nature, some of the parameters, some of the happenings occur at that time that was not well explained by this electromagnetic radiation, that is wave nature of the electromagnetic radiation, that will be explained by some other nature that we will discuss in the next video. So till then, all the best and be best.